Hi everyone, this is Ms. Hernandez, 8th grade science, and I'm going to go over some more information on the atom and its models. So we were able to go over the parts of the atom the other day, and I want to go over how to make a Bohr model. Okay, so first thing I'm going to do, I just have a regular piece of paper here. You can use notebook paper, you can use just a white sheet of paper, color paper, whatever you have. And I'm going to divide it into some sections. So I'm going to take the top third section, and I'm just going to divide that into threes, as even as you can. And I'm going to take the bottom section and divide that into twos. So that's all I have here. Let me zoom out a little bit. Okay. Doesn't have to be perfect, but if you want to take the time to pause the video and to set it up, you're welcome to do that. Okay, so I'm going to start with the parts of the atom. And I'm going to do that at the bottom. So the parts of the atom, let me zoom in a little bit. These are the bottom sections here. Parts of the atom are the nucleus, okay, and the electron cloud. Okay, these are our inner and outer parts, nucleus and electron cloud. And so we did talk about these sections when we did the last video. So let's just review some information. The nucleus is the inner part of the atom. Okay. It includes protons, which are positive, and neutrons, which have no charge. Okay. Protons and neutrons. What we may not know about it is that it's very massive. Very massive. And that's on the count that it has protons and neutrons in it. They add to the mass. It's all in the center of the atom. It's all giving you a lot of density. It's very, very dense because of our protons and neutrons. It's very massive and dense. And overall, it has a positive charge because it has the protons in it. Positively charged, okay? Intersection, very massive, positively charged protons and neutrons, okay, in the nucleus. Now we're going to move on to the electron cloud. The electron cloud is the outer part of the atom, okay? It's the outer part made of different energy levels, right? Has energy levels. And it can have up to 7 energy levels. Okay, has energy levels here. It has not protons, not neutrons, but electrons, right? It has that third one. It has electrons in it. And electrons are that negative charge. So electrons are incredibly small. We're going to talk a little bit about their size when we get to the top. Because they're so small, they have almost no mass. They add no mass. So that means the electron cloud has essentially no mass. And when I say no mass, I mean negligible mass, right? It's not measured. Not measured for the atom. Okay, excuse my writing. This is measured. Not measured for the atom. Almost no mass. But what it does have is a lot of volume. Okay, because it takes up space. So volume is how much space something takes up. So it has all volume, but this volume is mostly empty space. The reason being is these electrons are so small and your energy levels can become really large for the size of the atom that everything in between them is just empty. You have a whole lot of empty space. So nucleus, inner part, positive with protons and neutrons. Electron cloud, outer part, negative with electrons, has energy levels. Okay. Give you a second to write that down. You're always welcome to pause the video so you can write them. Now I'm going to continue to the top section. So the top, I have 3 sections here, and we could probably guess, I'm trying not to do that to you guys, We can probably guess what it is. Protons, electrons, and neutrons. The atom's 3 subatomic particles. Okay? Our protons are positively charged. Okay? They have a positive charge. Okay? Represented by the symbol P with the plus sign. They're found in the nucleus. In the nucleus, as I mentioned at the bottom. They have a mass of 1 AMU. We haven't really talked about the mass. A mass of 1 AMU, atomic mass unit. That was one of your vocabulary words this week. Atomic mass unit. And 1 may not sound like a lot, but 1 is very, very big in atomic terms. Okay? 1 AMU. So every proton counts as 1. The protons are very, very important for the atom because they identify the element they're representing. The protons identify the element. So when I see an atom model, I can count the number of protons and I can find what element it is because the protons equal the atomic number of an atom. And I'll show you this in your periodic table in your book in a second, okay? So protons equal atomic number, identify the element. That's why they're so important. A mass of 1 AMU found in the nucleus with a positive charge. Let's pop over to electrons. So electrons, negative charge, represented by lowercase e with a minus sign, negative charge. They're not in the nucleus, they're in their own cloud. They're in the electron cloud. In the electron cloud. And remember I talked at the bottom how the electron cloud has almost no mass but all volume? That's because of the electrons. The electrons have approximately, that's that squiggle means, approximately 0 AMU. Now, do they have 0 mass? Well, no, not quite. But it is so small, so incredibly small that we don't count it. You would need something like 1,400 electrons to equal 1 proton, okay? That mass is negligible. We just don't count it. So we say it has 0 AMU. I wrote approximately, but you'll see often they'll have 0 AMU or no mass, okay? Remember, AMU, atomic mass unit. And the electrons, generally the outer part of the electrons, are called valence electrons. They're used for bonding, right? So they're used for bonding. And this is to create molecules and compounds used for bonding. And what we use are the valence electrons. And I'll talk about that when we get into the model. Valence electrons are the ones used for bonding. They're just the electrons found on the last energy level. Your neutrons, no charge, represented by an N with a 0. No charge, sometimes called neutral. So I'll write that. I like to say no charge, that we're very clear on them, but sometimes they're called neutral. They're also in the nucleus along with the protons. In the nucleus. And just like the protons, they have a mass of 1 AMU. So they're very massive, okay? 1 AMU, 1 atomic mass unit. And for our purposes in 8th grade, that's all we need to know for the neutrons. In high school, you learn a little bit more about their function, but for 8th grade, we're going to focus on these 3 things. No charge, in the nucleus, 1 AMU. So now I'm going to come to my center portion, okay? So my center portion, I'm going to draw a Bohr model for the element lithium, okay? For the element lithium. And I'm going to use a periodic table. So I want you to look up a periodic table. There's one attached in your classroom information, but also you have one in your book. So let me show you. This is the one in your textbook. Okay, and this is on page 128 and 129 in your textbook. And the basic parts of an element box in a periodic table are the atomic number, the chemical symbol, the element name, and the average atomic mass. Remember I talked about the atomic number. I told you that the protons, you can actually see it right there, the protons equal the atomic number. So if I were to count the protons in an atom, let's say I had an atom of aluminum and I counted all those positive protons and I got the number 13, I just look for number 13 in the periodic table and I'm going to know that it's aluminum because this number, the atomic number, equals the protons. So I told you we're going to do a model on lithium. So here is lithium here. Lithium has an atomic number of 3 and it has a mass of 6.94. We're going to use just basic principles of math and we're going to round that up to 7. So atomic number of 3 and a mass of 7. So if this part you find a little confusing, we're going to work on it, okay? We're going to work on this. So I'm going to write atomic number 3. I keep turning the page, my apologies. And my mass number, remember, it was 6.94, but I'm going to round it to 7, make it a whole number, okay? And I have my model has to represent the parts of the atom, must include a nucleus, must include an electron cloud. I'm going to draw my electron cloud. Now, lithium has 2 energy levels. And we're going to get into how you find that information soon enough. So energy level 1, energy level 2, here are my energy levels. Okay, together, this is my electron cloud. And the center part is my nucleus. That's just me showing you the parts of the atom, nucleus in the center, energy levels, electron cloud. So what has to go in an atom? Well, I need to have my protons, my electrons, and my neutrons. And I like to say pen. We need to find pen. P-E-N. Protons, electrons, neutrons. Have to find pen. In order to find pen, we use a little device, little calculation device called Ape Man. Okay, Ape Man. And Ape Man stands for atomic number equals protons equals electrons. That's your Ape. A equals P equals E. Atomic number equals protons equals electrons. Okay, that's the Ape part, Ape. And then man, which is your mass equals atomic number equals neutrons. That's your man. I'm sorry, not equals. My apologies. Minus. That's going to haunt me there. Mass minus atomic number equals neutrons. Okay. M minus A equals N. Okay. So atomic number, separate these real quick. Get some minus sign. A equals P equals Z. M minus A equals N. And that's going to give me my protons, my electrons, my neutrons. And we're going to practice this a lot when I say that. I'm going to use this information to fill in my Bohr model. So I take my atomic number. Here's my atomic number, right? A, my atomic number is 3. So I have 3. And I got equal signs. Well, 3 doesn't equal 420. 3 equals 3 equals 3. So 3 equals 3 equals 3. That means I have 3 protons and 3 electrons because they always equal the atomic number. The protons always equal the atomic number. And if I have 3 positive charges in our atoms in the 8th grade, our protons and electrons are equal. So I have 3 negative charges, okay? 3 positives, 3 negatives. Atomic number, right, from the periodic table equals protons equals electrons. Now I have to figure out my neutrons, and that's what I'm going to use this little equation for. I'm going to take my mass number, right? My atomic mass number of 7. It was 6.94 on the periodic table, rounded up to 7. 7 minus the atomic number of 3 equals 4. You can use a calculator, you can mental math it, you can do whatever you'd like in order to calculate this. You do get a calculator for a STAR test. 7 minus 3 is 4, so I have 4 neutrons. And now I need to put them into my atom. So we already went over what's in the nucleus and what's in the electron cloud. In the nucleus, we have protons and neutrons. So I have 3 protons. I'm going to go 3p positive, right? 3 protons positive. How you choose to draw this or write this is up to you. Some people draw a bunch of circles or plus signs. Some people just draw plus signs. But I just want to use the symbols for it, okay? And as for my neutrons, 4 neutrons. And then I have to add my electrons into the energy levels, into the cloud. So my electrons, there are rules on how to follow the electrons, how to put them into the energy levels. One of the first rules that you'll learn is that each energy level can only hold a certain number of electrons. And we're only dealing with 3 electrons here in 2 energy levels. So the first thing is that the first energy level can only hold 2 electrons max. It can hold 1 or it can hold 2, but it cannot hold more than 2. And those aren't rules that scientists created. That's the nature of an atom. So my first energy level, I'm going to put an electron here, E with the minus sign, and I'm going to put an electron here, E with the minus sign, and I can't put any more electrons there. I can't do it. That's just not the way they're made. So I got to jump to the next level to get my third one. Because I have 1, 2, I need to put 3. I'm just going to put 1 right here, E with the minus sign. So now I have 3. This is my completed model of lithium. It's done. Okay. One thing I want to bring up is valence electrons. I mentioned it up here, right? Used for bonding, valence electrons, okay? They also tell you reactivity, how these elements react when they bond. Some of them are very, very reactive, and some of them are not reactive at all. And so I'm gonna write here, pen V, right? Valence electrons. There's a couple ways for you to figure out the valence electron number. But the easiest way to do it, if you have a model, is you're going to count how many electrons are in the last energy level. I have 2 energy levels, level 1, level 2 being the last level. And I'm just going to look to see how many electrons I have, and I have 1. So that means my valence electron number is going to be 1. That's my last one. It's still an electron. It still has the same mass of 0, has the same charge of negative charge. It's still in the cloud. But because it has a special purpose, which is bonding and reactivity, it has its own special name. If I had a third level, then I would count them off the third level. If I had just one level, I would count them off the first level. Whatever is the last energy level. So valence electrons, these are electrons on the last level, okay? So we have a completed, let me zoom out so you can see all this. We have a completed Bohr model of lithium, shown you how to work it out. We're going to talk about that in the next few days, giving you all the information. I mean, this is all the information you need for an atom. And so I hope that you find this really useful. You're welcome to take your notes as you need to. You can add it to your other notes, but this pretty much is going to sum up the information that you need in order to understand the parts of the atom. You're always welcome to pause the videos wherever you need to, and you can go back and look at them as you please. Thank you guys so much, and I'll see you in class. Bye.